Welcome back. We will continue our discussion of engines and of 2T heat engines for a while. First thing we should remember that any engine which we talk about, 2T or otherwise, is a cyclic device. It has to produce a positive amount of work. And in our discussions, unless we specifically say so, we are not interested in just now or not concerned with the materials used or the fluids used or even the details of construction or the details of operation. All that we need is that it be a cyclic device and that the work output or the power output of the engine should be positive. Now what we are going to do is the following. We have noted that our basic statement of the second law of thermodynamics is the Kelvin-Planck statement. This represents our statement and our understanding of the second law of thermodynamics. Now using this, we have shown that if we have just one thermal energy reservoir and if we attempt to make a so called 1T heat engine, then this is not possible. But if you have two different temperatures, then an engine, now we call it a 2T heat engine, will work by absorbing heat from one reservoir and rejecting heat to the other reservoir. Now let us have this nomenclature that reservoir T1 will be the one which supplies heat Q1, reservoir T2 will be the reservoir which accepts or to which the engine rejects the heat Q2, and we have shown that this is possible. And while doing this, we have used a method by which we have shown that if we assume something otherwise, for example, if you assume that this Q2 is also in this direction, then well, this will not be an engine because it would violate the Kelvin-Planck statement. This method is known as the method in which you assume something and then show using standard methods of mathematics and logic and show that it leads to some inconsistency. That means some basic statement which is accepted as true itself is violated, then we are sure that what we have assumed is incorrect. We will now use this technique to derive many characteristics pertaining to 2T heat engines and later on for related processes. Thank you.